Though not the first man-made satellite, Telstar 1 was the first active communications satellite. That is, it was the first satellite capable of amplifying signals before relaying them back to Earth. The implications of such technology were so far-reaching that this event was truly a turning point in history. In 1945, a science fiction writer by the name of Arthur C. Clarke envisioned a satellite system that would vastly improve communications. 10 years later, scientist John Pierce of Bell Laboratories seized on the same idea. On July 10, 1962, Pierce's ideas became a reality when the first active communications satellite, Telstar 1, was launched. With this single event, life for every single person on the planet was affected, directly or indirectly, when a small metal ball in the sky revolutionized communications and blazed a path for the development of countless technologies that we now take for granted. Decades of discovery preceded this remarkable moment in history, particularly Alexander Graham Bell and his talking telegraph. Bell and his two financiers founded Bell Systems in 1875. The first telephone exchange, a center where telephone lines interconnect, opened in 1878 in New Haven, Connecticut. By 1881, most major U.S. cities had telephone exchanges, and in 1885, AT&T was formed to operate these long-distance networks. In 1925, AT&T's new president made it the company's goal to provide universal telephone service. By 1927, electrical amplifiers made transcontinental communication possible via two-way radio, but the cost for a 3-minute conversation was $75. With inflation, that's the equivalent of $956 today. Clearly, this was an impractical way to communicate. How was the goal of universal phone service to be achieved so that the common person could afford it? About 70% of all American households had a telephone by 1955, but this was far from universal service. Overseas communication was still costly and unreliable at best. This began to change in 1956 when the first transatlantic telephone cable system came online. 2 cables had been laid, one for transmitting in each direction, 2.5 miles beneath the surface of the Atlantic Ocean across 1,950 nautical miles. Though cable capacity increased quickly, it was costly and difficult to maintain underwater. Meanwhile, microwave relay towers were being developed to improve overland communications in the United States. Because microwaves required line of sight for transmission, this required a tower approximately every 20 miles in each direction due to the Earth's curvature. That worked over land, but hundreds of microwave towers could never be built across oceans. In order to achieve transatlantic microwave communication, the tower in the middle of the Atlantic Ocean would have to be 475 miles high. John Pierce at Bell Laboratories came up with a solution that became Project Telstar. They had already invented transistors to amplify electronic signals better than the old tubes, and NASA had successfully launched rockets into space. Pierce thought that a satellite could be sent into orbit that would receive electronic signals from a ground station on Earth, amplify them, and retransmit them to other stations across the ocean. Powerful antennas at these ground stations would transmit and receive signals to and from the satellite. From those ground stations, the signals would be distributed to radio and television stations using existing technology. Would it work? Engineers at Bell Laboratories began building a satellite. It had to be small enough to load in the nose of the launch rocket, tough enough to function in space, capable of recharging its own batteries, and powerful enough to receive, amplify, and transmit various signals. The final product was the size of a large beach ball, 34 inches in diameter, 170 pounds, with over 15,000 components. It had 3,600 solar panels and over 1,000 transistors which, combined with the onboard traveling wave tube, could amplify a signal more than 10 billion times. Continuous communication with only one orbiting satellite would not be possible, but the primary purpose of Telstar 1 was simply to prove that the technology would work. It was also important for the satellite to collect and transmit data about the functioning of its components in space. This data would be used in the development of future satellites. Equally as impressive was the Great Horn antenna built at the Andover, Maine Earth Station. A massive 380-ton steel and aluminum rotating structure, it was so powerful that from Maine it could hear the sound of a feather dropping in Florida, thanks to the supercooled ruby maser deep inside it. To protect the antenna from the harsh weather, it resided inside the radome. Efforts were coordinated with the British and the French, and NASA agreed to launch the satellite. After 2 years of development and testing, the project was ready to go. In the early morning hours of July 10, 1962, Telstar 1 was launched from Cape Canaveral.
Minus 10, 9, 8, 7, 6, 5, open solo 4, 3, 2, 1, 0. Start. Plus 4.
Telstar was launched. 033500 on the button.
NASA's Thor Delta rocket delivered the satellite into an elliptical low Earth orbit between 600 and 3,500 miles high. The antenna's job was to continuously track the satellite while it was above the visible horizon as it orbited the Earth every 2.5 hours. It succeeded to within 1/50th of a degree. The first ever satellite relayed telephone call from AT&T chairman Fred Kappel was put through to Vice President Lyndon Johnson.
Good evening, Mr. Vice President. This is Fred Kappel calling from the Earth Station at Andover, Maine. The call is being relayed through our Telstar satellite, as I am sure you know. How do you hear me?
You're coming through nicely, Mr. Kappel.
That evening, a satellite image of the American flag in front of the Andover Radome reached the French ground station. For the first time in history, overseas audio and video transmission in real time had been achieved. Telstar 1 was a public relations coup. The entertainment and communications industries exploded, but there were much more significant implications with this new technology. National security was tremendously impacted with respect to our ability to perform surveillance, communicate critical information on a timely basis, secure communication channels, and maintain foreign relations. President Kennedy, in a satellite broadcast press conference, hinted at these very issues.
I understand that part of today's press conference is being relayed by the Telstar communications satellite to viewers across the Atlantic, and this is another indication of the extraordinary world in which we live. This satellite must be high enough to carry messages from both sides of the world, which is, of course, a very essential requirement for peace. I think understanding would inevitably come from the speedier communications is bound to increase the well-being and security of all people, here and those across the oceans.
New technologies continue to be formed that are, in part, reliant on satellites. While not all satellites are specifically for communications, one thing that they have in common with Telstar is the collection and transmission of information. People living in remote areas could not communicate without satellites, which is critical in emergency situations. Internet and cell phones both rely on satellites at various points. Navigation and weather prediction were greatly enhanced with the use of satellites. The aviation industry uses satellites to track aircraft. Some satellites provide scientific information about outer space, while others observe the Earth. Satellites are widely used in disaster response, environmental monitoring, and transportation and infrastructure planning. Conventional ways of doing business changed, and a global economy eventually emerged. And of course, there are countless military applications for satellites. Telstar 1 proved that satellite technology worked, but the satellite failed within a year due to atmospheric radiation from nuclear tests. The disabled Telstar 1 satellite is still in orbit 50 years later. Few events have had such far-reaching effects on the entire planet as the launching of Telstar 1. Today, approximately 3,000 man-made satellites circle our globe, of which about 2,200 are functioning. Some of the impacts are things we'd never consider, but others are essential parts of our daily lives. Imagine an internet that wasn't really a World Wide Web, or not being able to talk to someone overseas at a moment's notice. What would business look like today without worldwide communication? Our lives would be very different without these features. The launching of the first Telstar satellite truly was a turning point in history that forever changed our entire world.